wave speed. We're going to talk briefly about wave speed, which is not necessarily the speed of any particular point in the wave. It is the speed of the wave front moving through the medium. Remember from kinematics that your average velocity is your change in position over your change in time. So we can replace that here with the change of position of your wavefront in one period is lambda, and that time is capital T, your period. We also remember that the frequency is inversely proportional to the period. So we can actually combine those. So we get that the wave speed, even though it's written as v velocity because it does have direction, we call it speed. All right, it is equal to lambda times 1 over t, or lambda f. The AP equation sheet writes it this way. Algebraically, it's the same thing. Let's think back to our water pendulum that we did in class. If we sped up the paper, the wavelength got bigger. If we slowed down, the wavelength got smaller. That's because the wave speed is a property of the medium. All right, the speed of sound in water is the speed of sound in water. It doesn't matter what the frequency of that sound is, which we'll talk more about later in the week. In this case, the water pendulum, the frequency was set by the pendulum, so it didn't change. All right, the frequency is a property of the wave itself. So here's that is in summary, and your equation that is on your AP equation sheet.